Okay, this is exercise 1D from the AQA textbook, proof by deduction, question 1 to 4, so the green questions. Let's go. So question 1, prove that if n is odd, then n squared is also going to be odd. And with proof by deduction, you've got to use either algebra or words or something to prove this. You can't just go and use a numerical example. So what the question is saying is saying if n is odd, so if n was equal to 3, for example, if you square it, you're going to get an odd number. And we can see with this example here that this is true, but of course, this is not going to cut the mustard, okay, because you've got to prove it for all cases. And to do that, you've got to use algebra. Okay, so if n is odd, well, then we're using our definitions from the last video. How can you write an odd number? Okay, well, let's go and do that. So we're saying if n is equal to an odd number, and don't write it as 2n plus 1 because we've already used that letter n in the question. So call it something different, like 2k plus 1. Okay, so this is our odd number. If we take n squared, it should also be odd. So if we go and take n and we square it, okay, so we've got to go and square this 2k plus 1, okay. If we sort of go and manipulate this bracket and we expand it, sorry, that square is not written very well, we should get an odd number, okay. And remember, if you're trying to prove something it is odd, you kind of, right, the aim of the game is to perhaps factorize out maybe like a 2, have a bracket, have something there, and then you want an odd number plus or minus on the end. So for example, plus 1. That's the kind of format that we're going for here, okay, because then this must be an odd number. So now, okay, if I go and take this bracket here, and let's just go and manipulate it. So we're going to be taking 2k plus 1 and expanding this double bracket. Okay, so expanding brackets, 2k by 2k, 2k by 1, okay, and then we follow through. So 2k by 2k is 4k squared, 2k by 1, there's 2 of it, so plus 4k plus that 1 on the end. And then here, what I'm going to go and do is I'm going to go and factorize out I'm actually going to go and factorize out a 2 here, not a 4, just because I like to have 2 outside my bracket. You could go for 4, it makes no difference here. But I'm going to factorize out a 2 from this and get a 2 bracket 2k squared plus 2k. So I've just factorized out the blue part. These two things mean the same thing. But importantly, right, I've got plus 1 on the end. Now, this 2k squared plus 2k, this is just some integer, okay? It looks a little bit untidy. I'm going to tidy it up in a second, but let's just say that k was equal to 1, for example. Who knows what it's equal to? It would be 2 by 1 squared, so 2 plus 2 by 1, which is 2, so 4. So this part here is just some integer. But actually what I'm going to go and do is I'm going to go and replace this bit here and write it more concisely, because that's always a good thing to do in maths. So I'm going to let x be equal to 2k squared plus 2k, okay, where this x here is just some integer, which means I can kind of write this more simply as 2 times by x. I've just replaced this bit again with x to make it written more concisely, but importantly I've got that plus 1, which is still hanging on the end, okay. And importantly, right, because with the proof by deduction you've got to talk about everything that you're doing. Well, 2x is just your 2 times table, which must be even. So 2x is going to be an even number, and if you plus 1 to an even number, you must get an odd result. Okay, so there we go. If I zoom out, you can see, okay, I've proven by deduction, I've gone through a logical argument, okay, defining first of all my odd number to be 2k plus 1, and I worked through in steps to get to my final answer, using algebra to prove all cases, and then words just to help me justify my argument. Okay, that was question number 1. Question number 2 says this: prove that the sum, so adding an even number and an odd number, is always odd. So again, similarly with this kind of format here, okay, the key things here, we're summing, so we're adding an even number, which we can define. Odd number is always going to be odd. So, okay, an even number, we can write something like 2n. Let's do it in red, sorry. So an even number, let's write it as 2n. An odd number, right, because in this question, they're not talking about consecutive numbers, you want to keep things as random as possible. So writing the odd number as 2n plus 1, even though it's not wrong, it isn't as random as it could be. Okay, so let's go and write it using a different letter, like 2m plus 1. So 2m plus 1. And we're saying that if we sum these together, it's always going to be odd. So again, we're kind of looking for a format where you've got maybe a bracket and you've got 2 factorized out, you've got something integer factorized in the bracket, and then you've got plus an odd number, usually +1 or something on the end. And that is what we're going for with this, because again, this part here, if you take a 2 outside a bracket, this must be even, this part here, and then +1 or plus an odd number, it must be odd. That's what we're looking for here. Okay, so the even number is 2n, and we're summing it to the odd number, so 2m plus 1. And now we can go and factorize out a 2 from the 2n and a 2m to get 2 bracket n plus n. I've just factorized this part to give me this here. Importantly, I've got this plus 1 again on the end. And again, right, this n plus m, which is here, it is just some integer. We can write it a little bit more concisely. So I'm going to be writing this n plus m to be equal to another letter like x, okay, where x is just some integer, some whole number. So I can write this as 2x plus 1, okay, and 2x is just going to be your 2 times table, which is an even number. Okay, so 2x, it must be an even number, and again, an even number plus 1 must give you an odd result. An even plus 1 must give you an odd result, an odd number. Okay, good. Question number 3 says this: prove that the sum of any 3 consecutive, so in a row, like 2, 3, 4, 5, 6, 7, for example, is always a multiple of 3. So in this one, if you're proving something is a multiple of 3, you want to have 3 outside a bracket with some integer inside that bracket, okay? And importantly, again, sum means you're adding, and consecutive means in a row. So 3 consecutive integers we can write like this. N is just a number. It could be n, could be 3, it could be 10, it could be a million, it could be whatever. Consecutive means you're plussing 1 each time, so it's going to be n plus 1 and then n plus 2. So for example, if n was equal to 3, for example, we'd have 3 plus 1 is 4, 3 plus 2 is equal to 5. We are summing them, so we've got to go and add them together. So let's go and do that. So we're doing n plus 1 plus n plus 2, okay, which is equal to 3n, and then 1 plus 2 plus 3. Factorize out the 3 because that's what we're trying to do here. So take out the 3 to get 3 bracket n plus 1, and that's really going to be enough. But again, I like to write this part here, this bracket part, more concisely. Again, n plus 1 is just going to be some integer, some number. N could be again 3, for example. 3 plus 1 is 4. Don't let this put you off. It is just some number, some integer. I'm going to write this n plus 1. Okay, I'm going to write n plus 1 as equal to x. It just makes things more concise. It's writing things more clearly. And x is some integer. So x is just some integer, which means I can write this now as 3. N plus 1 I've replaced with x. And we know, okay, that 3x, okay, by definition is the 3 times table. Okay, so 3x is a multiple of 3, which is exactly what the question wants. Okay, prove is a multiple of 3. 3x is a multiple of 3. Okay, perfect. Question number 4, last of the green questions. We've got prove that the sum, okay, so adding 2 consecutive multiples of 5 is always odd. So we want to look at if we add together 2 consecutive multiples of 5, they're going to be odd. So that's looking at things like 5 and then 10, or for example 100 and 105. It's the 5 times table but consecutively, and 2 of them. So how can I write 2 consecutive multiples of 5? I can write them something like this. So 5n would be 1, for example, and then to get my consecutive one, it's going to be written as this. So 5 brackets n plus 1. And let's just check that makes sense. If n happens to be equal to 2, we'd have 5 by 2, which is 10. N is 2 still. N plus 1 is 3. 5 by 3 is 15. We've got 10 and 15. So indeed, this algebra, it does produce consecutive multiples of 5. If you weren't sure, just try some numbers, okay, and make sure it works. And let's say if we sum them together, we always get an odd result. Okay, so let's go and do that. So let's go and take 5n, and let's go and sum it, so add it to 5, and we're going to go and expand the bracket, so 5n plus 5. I've just expanded this bracket. 5 by n is 5n, 5 by 1 is equal to 5. Let's add these two things here together, so 5n plus 5n is 10n, and then plus 5. Okay, what I could do here is I could factorize out a 2 from this 10n. But I don't really need to. I could do that. That's kind of what I've been doing from the start. But actually, the 10n, it must be an even number. Okay, the 10 times table, 10, 20, 30, 40, 50, they're always even numbers because they end in a 0. So I'm just going to go and write here that 10n, okay, it must be even. You could, if you really wanted to, and actually I would maybe rewrite it like this, but I'm not going to because you don't need to. You could write this line here, 10n, you could take out a 2 and then write it as 5n, and you got that plus 5 on the end, okay? And then you could rewrite that 5n, something like 2x plus 5, because then, right, I don't know, it's just formality. I like to have like the 2 just because that's what I like to do. But this means exactly the same thing as this over here, okay? Just a different way of writing it. Anyway, I haven't gone for that, but you could do if you wanted to. Anyway, continuing on over here, okay, 10n, it must be an even number, and if we plus 5, okay, it must be odd, because an even number plus 5 is always going to be odd. So an even number plus 5, okay, must be odd. Okay, and you have got to really write that, because when you go proof by deduction, you've got to talk about every single step. Okay, so there we go. That is that one done, and we can move on to part B, which we're going to go and do over here. So that was part A, and then part B, let's do it over here, which says prove that the product, so timesing this time, of 2 consecutive multiples of 5 is always even. Again, okay, let's just rewrite our consecutive multiples of 5. So over here, so 5n bracket 5 bracket n plus 1. Okay, and let's just manipulate the algebra. So we're looking at the product here, which is multiplying, so let's go and do 5n. We're timesing it through by 5 bracket n plus 1. Well, what I would do here is just expand this bracket. It's always a good thing to do. So 5n times by 5n plus 5. And then, sorry, let's be really careful. I'm writing this, right? I'm being very, very clumsy here with how I'm writing this. That should be in a bracket, okay? Otherwise, it's not going to make sense. 5n by 5n is going to give me 25n squared, okay? And then 5n times by, my highlighter, 5n times by 5 is going to give me plus 25n, okay? Just making sure I've made no mistakes there. No, it looks all good. Okay, it looks all good. And then, what can I do here is I could factorize out a 25 and an n, okay? I'm just, you know, when something is always even, you're always going for that logic where you want to try and take out a 2 if possible. In this case, it is not looking like that's going to be working, but let's just kind of manipulate the algebra and see if we can come up with something. That is what I'm thinking right now with this. So what I'm going to go do with this is factorize out a 25 and an n, because then we get n plus 1, okay? And then what is going on here? Well, either, okay, because I've now got this n part and this n plus 1 part, either n or n plus 1 must be even because they're consecutive numbers, okay? So in this case, right, either n or n plus 1 must be even, okay? And if either n or n plus 1 is even, it must mean that, well, if this was even, this times whatever that is must be even. If this n was even, it would make this even. You times that by that, you're going to get an even number. A lot of words there. Let's try and write that a little bit more clearly. So something like this, and let's do it down here. So something like, right, either n or n plus 1 must be even, okay, which means that this must have a factor of 2 somewhere, because either this part here is going to be even times by anything is even, or this part here, if that's an even number, is going to be even, so that times by anything is going to give you an even number. So either n or n plus 1 must be even, okay. Therefore, so thus there will be a factor of 2, okay. Thus we get an even result. Okay, hopefully I explained that clearly. What's important there is, okay, again, I've gone through all these questions, I've gone through some algebra, and in this case, some written arguments at the end. Okay, thank you.